Hello, I want to do another example on the Lorentz transformation. And in this example, I want to show that if two events are simultaneous in one reference frame, they will not be simultaneous in a second reference frame that is moving relative to the first. And I'm going to use the example that we've been looking at regarding simultaneity. Basically, we're going to look at the railroad car that's moving to the right with speed v. The railroad car here is denoted in blue. And the observer in the railroad car will be denoted as O prime. And the observer in our frame, the lab frame, will be denoted with the letter O. So the black reference frame that you see here is our frame. It's what I would call a stationary frame. It's stationary relative to us. And it's denoted by the unprimed coordinates. And the blue is the prime coordinates. It's the moving frame. So as this railroad car moves to the right, observer O sees lightning strike the front end and the back end of the train simultaneously. So according to what we're going to denote this point as F, or X of F, and this is the back of the train, or X of B. So lightning strikes the front end and the back end at the same time. Since the two events occur at X1 and X2, I'm going to write delta X as X2 minus X1, or I can write it as the difference in position between the front end and the back end of the train, X of F minus X of B. Since the two events occur at the same time, then T2 minus T1 equals 0. So T2 is the time at which event at X equal 2 happens, and T1 is a time in which event at X equals X1 happens. Or we can write it this way. We can say that the time in which the event happens at the front minus the time in which the event that occurs at the back equals 0. Now what I want to do is take a look at the time difference between the two events as measured with respect to O prime. And we're going to use the Lorentz transformation for that. So let me write down the Lorentz transformation for time. T prime is equal to gamma times T minus X V over C squared. That's for one time. We're going to be looking at a time interval between two events. So we got to take the time difference between two events that occur at two different locations. And so we'll write delta T prime is equal to gamma delta T minus X V over C squared, or delta T over, let me rewrite that. Delta X V over C squared. Okay. Now, since the two events occur at the same time in O's reference frame, then delta T is 0. This goes away. Remember, everything in this top equation you see here is measured with respect to O. So since this is 0, our time difference between the two events as measured in O prime's frame is given by minus gamma delta X V over C squared. Now, let me write this out a little bit more. So this is going to be T2 prime minus T1 prime. Or I can write it as T of the front prime minus T at the back prime. This is equal to minus gamma delta X V over C squared. Notice that if the two events occurred at the same place, delta T in both frames would be 0. The events would be simultaneous in both reference frame if delta X was 0. But it's not in this case. The two events occur at different locations. Now, when you look at this equation, this tells you that the event in the back of the train happens after the event at front of train. In other words, T sub B prime is bigger than T sub F prime. Okay, T sub B prime is bigger than T sub F prime. Okay, so that the time difference between the two events is given by this expression, according to O prime. But what about O? If O prime measures that time difference, O is going to say, oh, well, the clocks in O prime run slow. So I'm going to say the time difference according to O is going to be bigger by that factor of gamma. So I'm going to write capital T is equal to delta T prime over gamma, which is going to give us minus delta X V over C squared. So according to O, this is going to be the time difference between the two events measured by O prime. Now, the clocks in O's frame are synchronized, and the events occur at the same time in O's frame. If this is the time difference between the two events as measured by O, let me rephrase that. If this is the time difference in the moving frame as is measured by O, that's going to say that the clocks in the prime frame are not synchronized. How much? By how much are they not synchronized? By this value. So O is going to say the clocks in the moving frame are not synchronized by this amount. Why? Because, well, if the clocks in O's frame are synchronized and the two events occur at the same time, then, and if these two events do not occur at the same time, that means that the clocks in the prime frame are not synchronized, and this is the amount by which the clocks are not synchronized.